previous class, we developed a up counter verilog code, right? So in this class, we are going to develop a down counter verilog code. Okay. So I'm using here module keyword and I'm giving a name down counter. What are my inputs? Clock and reset, right? Clock, reset. When it comes to output, we are planning to develop a 4-bit counter. So I'm just taking here 4 bits. It is nothing but 3 down to 0 out. Okay. Here I am using the always keyword. Accurate is nothing but event. My output has to be come at every passage clock. So I am giving here passage clock. If you want to negate, you can change it to it is a negate. Okay. Begin. If reset equals to 1, our circuit will not work. So I'm just declaring my output as 0. If reset is 0 means it has to work as a down counter, right? So out minus 1 and the module. Our code is completed. Now I'm just saving with a name down counter dot v. Now we will compile this code. For that, in terminal we have to give a command verilog and file name. Our file name is down counter dot v, right? So I'm just giving the. If you see here, we are facing one error. That is okay. We have to before that we have to give a and right because here there is a begin right. So here I'm just modifying my code. Okay, here also we missed the data type which you see here. Now our down counter is successfully compiled. Now we will write the Testbench for it. For Testbench, I am taking a one more file. Here I am declaring the name down counter TB. Okay. Now for inputs we have to take a rich data type. Inputs are clock and reset. When it comes to outputs, we have to take a wide data type. Output size is 3 down to 0, and I'm declaring as a out variable name as out. Okay. Now I'm instantiating a design module name here in my testament, and I'm giving the name as P1 dot clock equals to clock dot reset equals to reset and dot out equals to out. First we have to uh, generate a clock, right? Initial begin. We can generate the clock in two ways. One is forever. We already discussed that in previous class. You can see in previous video. In that video, we are generated a clock by using forever. Now we will see by using always. These are the two methods to generate a clocks. Okay, clock equals to 0, and we can't use always here. Why? Because we can't take one procedural block inside another procedural block. Here, initial and always both are procedural blocks, so we have to write outside of the procedural block that one. Always outside clock equals to negation of clock. Now we have to give a inputs. Inputs is nothing but here reset condition only. If it is a 1, our circuit won't work. After 20 seconds of delay, we can give, we can make our reset equals to 0. At that time, our circuit will work. Okay, and module. I am just saving my file down counter tb.v. Here in command file, I'm giving that name down counter tb. Right here, if you see, My test bench is successfully compiled. Now we have to simulate the waveform. For that, we need to give a command Vlsi and Testbench module name. I'm just paste, copying my Testbench module name and paste store in the terminal. And I press then enter. If you see here, now the waveform is simulating. Okay, it will open this window. Just right click on it, add to where all items in region. Now all the inputs and outputs were added in the waveform. If you see here, the clock and reset are the inputs and output is our output variable, right? So here I'm just pressing the run. I'm just maximizing. See here, now it's working as a down counter. It's slowly decreasing. First it's taking as a 15, 14. Again, if you observe one more thing, every passage clock only the output is getting. Why? Because we are giving a condition as passage, right? So every passage clock it's going down. Why it's taking from 15? Because uh, we are declaring as a 4-bit counter, right? The 4-bit counter maximum value is 15, right? 0 to 15. So from 15, it's slowly decreasing. If you want to see completely, just press run one more time. Then you can see remaining waveform also. Okay. This is how we have to verify the down counter waveform.